So let's see more questions asked in Thadomal Sahani Engineering College regarding automata theory SEM 3. The question is differentiate between DFA and NFA. DFA means deterministic finite automata, NFA means non-deterministic finite automata. The best thing we can do, is that we can see question 4, 5 and 6 first, and then we will come to differentiate. Okay, here we go. Question number 4. Construct deterministic finite automata for language accepting strings ending with ABB over sigma is equal to AB. Now, what is the answer for this? Is we have to draw a diagram where the first state or the initial state is Q0. Our DFA starts with Q0 state, and which string should be accepted by this DFA? Only those strings which end with ABB. So what you do, you ask yourselves which is the smallest string that should be accepted. Imagine we give ABB as the input. This is the string we give as the input to our DFA. Should it be accepted? Yes, it should be accepted because ABB is the string which ends with ABB. So minimum length string that should be accepted is ABB because it ends with ABB. So what you do is you draw a simple path showing edges ABB should be accepted. Finished. Name these states as Q1, Q2, Q3. Okay, but the point is that it should end with ABB. Now if I leave this DFA as it is, then it will accept only ABB. I mean, what should Q0 do if it receives B? Just imagine we give arbitrary number of B's before this. BBB, ABB. Yes, it is still ending with ABB, note. So we'll say Q0, if you get B, you keep looping here. Now read this, B, B, stay in Q0, then ABB, A, B, B, reach the final state. So for Q0, for the first state, we have given the transition for both B and A. What should be done if B is read by Q0? What should be done if A is read by Q0? Now think of Q1. Q1 has B transition, but we should give A transition also. Notice we want string which ends with ABB. What if the string is like this? You watch. Just imagine BB, ABB. Yes, the string is still ending with ABB. First two B's will be taken care by this loop. Then we have A. Okay, we change the state and go to Q1. We have arbitrary number of A's now. Do you understand? If we loop here, then we will get A, then B, B, it still ends with ABB. Correct? So Q1 now has both transitions A and B. Okay. Now think of Q2. Q2 has transition for B, but it should have transition for A also. Correct? What should string end with? ABB. Just imagine we have a string like this, BBB, then A, B, okay, then A again, some arbitrary A's, then BB. It is still ending with ABB, correct? But you watch, these triple B's will be taken care by this loop. Then we have this A, we will change the state, okay, we'll change the state, go to Q1. These two A's will be taken care by this loop. Now this B will be this transition, this one, and now suddenly we have A. We don't have B. If we had B, we would have gone to final state. Think of this, think of this. What you should do? You should not loop. You should search for ABB again. You should go back here, ABB. If you loop here, imagine, you say, okay, arbitrary number of A's, I will loop like this. I'll put a loop. Then even this string will be accepted. You watch. Triple B, then triple B, then A, B, AB. Notice this doesn't end with AB. This doesn't end with ABB. Okay, it ends with AB. String should end with ABB. Correct? Now, what will happen? These triple B's will be taken care by this loop Q0. Then this single A, we will change and go to Q1. This double A will be taken care by this loop. This B, we will change and we will go to Q2. Now this A, will be taken care by this loop, and then after that we have B, and B will take us to the final state. So it will say that this string is accepted, but this string should be rejected. Please try to understand that we want string which ends with ABB. So if we get A, then B, and then A again, A followed by B, and in this state we get A again, then we should search again for A, B, B. Correct? Okay. So Q2 also has both the transitions A, B. Now what about Q3? Don't put a loop here, because the string should end with ABB. So what you should do if you get A? If you get A, you should again go back to this state, because if we have a string like this, imagine triple B, then A, B, B, A, B, B. Check that the string ends with ABB. So in Q3, if you get A, you send it back so that if it is followed again by ABB, it will be accepted. And what if in Q3 you get B? If you get B, after ABB you get B again, then you will have to send the control. You will have to send the control back to Q0, so that you again search for ABB. So after this B, you are back to Q0, and if you have ABB only, then you will reach the final state. This is the DFA for the given question. Now, what you should do besides drawing this DFA, you should also write how many states are there. Q is Q0, Q1, Q2, Q3. Like this you should write. Then what is sigma? Sigma is given in the question, A comma B. Correct? And most importantly, you should draw transition table, delta. But that delta will be drawn by seeing this picture. What will be delta drawn? See, delta will be Q0, Q1, Q2, Q3. These are the states. It's a table. Delta is a table. And what are the inputs? The inputs are A or B. Tell me, Q0, when it reads A, it goes to Q1. So you write Q1. How do you read this? In the state Q0, if you get A, you will go to Q1. Then in the state Q0, if you read B, you will stay in Q0. Are you following this loop? Here we have given this loop. In the state Q0, if you get B, you will stay in Q0. That is what we have written. Similarly, Q1A stays in Q1, Q1B goes to Q2, Q2A goes back to Q1. Note this, Q2A we have drawn goes back to Q1. Then Q2B goes to Q3. Q3A goes back entirely to Q0, and Q3B, where is B? Oh, I missed out B, I think. Yeah, B. Q3B goes to Q0. I am so sorry. Q3B goes to Q0 and Q3A goes to Q1. This is what you should draw always. These three things you should write. And who is the initial state here? Q0 is the initial state. And who is the final state? Q3. So you show Q0 with an arrow and Q3 with an asterisk. When you do this, then reader will understand, or paper corrector will understand, that Q3 is the final state, Q0 is the initial state. Okay. This becomes the answer for the first question. Just make a note of it. Okay. What is the answer for second question? Just check. DFA that accepts the language over A comma B such that L is a set of all strings starting with AA or BB. So the first two letters should be AA or BB. Note this is another question. Okay. But first two letters should be AA or BB. So tell me, if you are drawing a DFA for this Q0, smallest string accepted should be AA, because AA begins with AA, or smallest string accepted should be BB. So what you do is, you draw two paths. AA should be accepted, or BB should be accepted. And then label this Q1, Q2, Q3, Q4. So tell me, if you feed the string AA, this path will be taken and AA is accepted. Correct. AA starts with AA. Or if you feed BB to this DFA, BB, then it will take this path and BB reaches final state. But what about the remaining transitions? Remember, strings that begin with AA or BB should be accepted. So what if you give this A, B, A, B? Does it begin with AA? Yes. But then what about these symbols? So you have to talk about Q1 now. After first A we will be in Q1. Then second A we will be in Q2. You only tell me, if you are in Q2, you know that first two letters are AA, then you say it makes no difference whether you get A or B after this. First two letters are AA. Now who cares what is there after that? It can be A, B, B, anything. So in Q2, if you get A, stay in Q2. Or if you get B, stay in Q2, don't leave the final state. Here also, if the first two letters are BB, then who cares what is there after that? Correct? So whether you get A or B after the first two B's, then you stay there in the final state. Tell me, if first two letters are BB, from Q0, first B traced, second B traced, so you know first two letters are BB. Now whatever you get after this, A or B, whatever, you will not leave the final state. Okay. Now you see, for Q0 we have given A transition, B transition. For Q1 we have not given B transition. Are you following? We have not given B transition. Now what does it mean? If Q1 gets B, what does it mean? If Q1 gets B, that means first letter, just check, first letter we gave in our string was A, that's why we came here. Second letter is B, it should be rejected, this string should be rejected because first two letters are AB, it should be rejected. So we create one new state called QD, dead state. And now once the machine enters this dead state, you know, it will never ever go anywhere but stay here. Now whether you get A or B, who cares? You will not move from this dead state. Think of this. String must begin with AA or BB. Suppose you know first two letters are AB. Check this path, A followed by B. First two letters are AB. Then whatever is there after that, you will always reject the string. You stay in the dead state. Okay, here we go. For Q3, what will happen if you get A in Q3? See, if you get A in Q3, that means first letter given was B. That's why you reached here. Second letter given is A. So clearly this string should be rejected because string must begin with AA or BB. So you will send this also to dead state. Tell me, if you are given a string like this, BA, now you know first two letters are BA, but you want BB, first two letters. So whatever is there after that, you know, you will always reject. The entire string will be rejected. You go to the dead state. And this is the DFA. Okay. Now, how will you draw DFA for this problem? I'm just erasing the screen. This problem. This is a regular expression which says string must begin with ABA followed by any combination of A or B. Then the DFA will be like this. A, begin with A, B, A. Final state. First three letters must be ABA. Now you tell me, if I give smallest string ABA followed by nothing, you know epsilon is covered in this. Nothing is covered in A plus B star. So ABA will be accepted. Begins with ABA, isn't it? Accepted. So now you say Q0, Q1, Q2, Q3. Now you tell me, if ABA are the first three letters and after that you have anything, whatever is there after that should be accepted, because first three letters are ABA. So once you reach ABA, you will say, who cares whether it is A or B? I will not leave this state. Now this A or B, I am showing it as two arrows, but you can show it on one arrow itself. You can write like this, A comma B. This means same as drawing two arrows. We are saying Q3, if you get A, don't go anywhere. Q3, if you get B, don't go anywhere. So A or B, you can write like that. But actually this means two arrows. One labeled as A, one labeled as B. Okay. Now here is the puzzle. What if Q0 gets B? Dead state, QD. Dead state. Because if Q0, the first state, the very first state, Q0 gets B, and we want the string must begin with ABA, but the first letter itself is B, it doesn't match the first letter A, then gone, you will reject the string, correct? And once you enter the dead state, you will say the string is rejected, so I will not go anywhere. Okay, let's talk about Q1. After A, after the first letter A, you get A again, but you want A, B, A, correct? So you will go to dead state. If I get second letter as A, okay? Now let's go to Q2. In Q2, if I get A, B, after that B, but first three letters I want A, B, A. So if I get B, I will go to the dead state. This is the DFA for the required problem. Okay? And remember, you should write the states. Q is Q0, Q1, Q2, Q3, QD. You should write final state is Q3. You should describe. You should draw the transition table. Okay? Now, what is the difference between DFA and NFA? Let's come to that question. Differentiate between DFA and FA. First, of course, you write full form. Okay. DFA stands for deterministic finite automata. And what does NFA stand for? Non-deterministic finite automata. NFA, okay, first difference. Okay. The second difference is that in DFA, you know, every state, you know, DFA has states like Q0, Q1, Q2 and so on. Every state will have exactly one transition for every input symbol. Okay. Think of this. Suppose sigma is A comma B. Only two symbols are there and we are drawing Q0 state. Then Q0 must have a transition for A, must have a transition for B. Now Q1. Think of another state in our DFA. Q1 is a state, so it should have a transition for A, it should have a transition for B. Exactly one. Every state will have exactly one transition for every input symbol. Okay? Now let's see NFA. A state, any state can have multiple transitions or no transitions. or no transitions at all for input symbol. Just imagine sigma is a comma b. This is our input symbol, and we have q0 state. NFA will also have states. Okay. Now suppose I show a q1 q2. Think of this. Now I ask you a question. In q0 state, if we get letter A, in q0 state, if we get letter A, then in which state you will go? In which state you will go? You will say, I will go to q1, but I can go to q2 also. Because when q0 is getting A, see, the machine can move to q1 or it can move to q2. That means multiple transitions can be there for a given input symbol. Are you understanding the meaning of non-deterministic? Non-deterministic. Why? Because if I ask you, you are in q0 and you get A, where will you go? You are in q0, you get A, where will you go? You will say, I don't know, sir, I may be in q1 or I may be in q2, because both are labeled as A. But I say, no, tell me exactly in which state you will be. You will say, I don't know, sir, it might be q1 or it might be q2. Non-determinism. But here in DFA, if I ask you, you are in q0, you are in this state, and where will you go if q0 gets A? You will say, exactly I will go to q1, because there is no scope of having multiple transitions for A. Every state should have exactly one transition. Deterministic, that's the word, deterministic. You can determine the next state. Here there can be multiple states in which the machine can be. That's the second difference. Okay. Now how will you write third difference? I am just erasing the screen. You can obviously backtrack the video and you can watch these points. So I'll continue writing the differences. Two differences. First one was the full form. Second one was this very important difference. Okay. Now the third thing what you should do while writing difference between DFA and NFA is you should draw an example. And any example that we have seen in the past for DFA you can draw, correct? For example, if I draw this DFA, Q0, A, Q1, A, Q2, final state, okay, A comma B. Do you understand? This will accept only those strings which begin with AA. First two letters are AA, only then it will accept. This is like AA followed by anything, A or B star. Okay. But we have to give, see, sigma here is A comma B. We have to give transition for B also. So it should begin with AA, correct? The string must begin with AA. So if the first letter is B, you know, if the first letter is B, we will send it to dead state. Once we are in dead state, we will not leave this state. And if the second letter after A, you get B again, you will go to dead state. This is it. Now, do you find any DFA you can draw, okay, any DFA in the third point of the difference? Do you see that every state is having transition for A, transition for B? Look at Q1. It is having transition for A, transition for B. Look at Q2. It is having transition for both A and B. Look at QD. It is having transition for both A and B. But in NFA, there is no such rule. You can draw it like this. You see, Q0, A, Q1, A, Q2 is the final state, AB, that's all. How do you read this? String must begin with A followed by A, first two letters should be A, followed by anything. Oh, hello, but what about B? If Q0 reads B, what will happen? If Q1 reads B, what will happen? We are not bothered. While drawing NFA, we may skip some input symbols for some states. Or you can draw another example. You can draw like this. Some arbitrary example. If you get A, you loop. but if you get A, you go to Q1. If you get B, you loop, but if you get B, you go to Q2, and this is the final state. And then if you get A or B, you stay here. Do you see Q0, has multiple transitions on A, and it never has transition for B. Q1 has multiple transitions for B, and it never has transition for A. So it is clearly a NFA. So one such example of DFA and NFA you should draw. Okay. The last thing you should do is that draw transition table. You remember that delta, the table you should draw. Okay. So I'll just erase the screen. I'm writing the fourth point now. Fourth point. This is DFA, NFA. Imagine we have a DFA like this. Q0, A, Q1, A, Q2, final state, AB. And if you get B here, if you get B here, you go to dead state, QD, and QD on AB will stay here. What will be the delta of this table? The table will be, we have two input symbols, correct? A, B. How many states we have? Q0, Q1, Q2. Now, Q0 on A goes to Q1, Q0 on B goes to dead state, because first letter cannot be B. We are saying that sigma is A comma B, and string should be of the form AA, A plus B star. First two letters should be AA. Now, Q1 on A goes to Q2, and Q1 on B goes to QD. Observe, Q1 on B is going to QD. Q2 is the final state, and Q2 stays in Q2 on A and B. Listen, I am not saying that you should draw this DFA only. Any DFA you draw, but you show the transition table. Okay. Now imagine some NFA you draw, like Q0, A, Q1, A. Imagine we have a loop here. Purposely you draw some NFA which has multiple transitions. Q2, final state AB. Now what will be the delta of this? We have two input symbols AB, correct? And what about the states? The states we have is Q0, Q1, Q2. Q2 is the final state. Q0 is the initial state. Now you tell me, in Q0, when the machine reads A, where can you be? In Q0 state, when the machine reads A, you can be in Q0 or Q1. So in Q0 when you read A, in Q0 state when you read A, you can be in Q0, comma Q1. You draw it always as a set. Entries in the transition table of NFA is always a set. Okay, tell me. In Q0 when you read B, check, have a look at Q0 state. In Q0 state, have you given B transition? Have you shown it in NFA? Q0, what will you do if you get B? You have not given it. Then you draw empty set. You are saying that Q0 does not take any action on reading B. It doesn't go anywhere because we are not given transition. Okay. Q1, observe Q1 state. What it does on reading A? Nothing. There is no transition for A. What it does on reading B? It can go to Q1 or Q2. See, multiple transitions. So show it as a set, Q1 or Q2. Now Q2. Q2 on reading A stays in Q2. Q2 on reading B stays in Q2. But every element you show it as a set. Even if there is a single state, you show it as a set. This is the last difference that you should do. First, full form. Second, DFA has single transition for every input symbol. Exactly one transition for every input symbol. But NFA can have multiple transitions or no transition. Third difference, draw a DFA and NFA. Fourth difference, draw DFA, draw its table, draw NFA, draw its table, show that each entry in the table looks like a set. So this is it. This is difference between NFA and DFA. That's it for this video.